So now there are certain number of advantages of this object oriented design. The first one is code as well as design reuse. Okay, because of the concepts that we have seen, there are very important uh, concepts of object oriented programming like inheritance. uh, by which you will be able to certainly reuse the code, as well as similarly we can reuse the design also, right? So it is going to give you a very better productivity because of this object oriented programming language or the object oriented design that we are going to use. Okay, because of that we see there is a increased productivity. And it is also uh, very much easy for the testers, as well as the while we doing maintenance of our software. So it also helps us, right? Better understandability. So we should be able to understand the complex problem in a better way because of its nature, very similar to the real world things, because here everything in terms of objects that we usually understand the concept of objects, right? So it's agreed that increased productivity is chief advantages. So this is one of the very important no, advantages of object oriented design. So when we use any object oriented technique or the design, so initially maybe the cost of development a little bit higher, but once when you move towards the completion of the software project, you will see so the amount of cost uh, that is invested gets reduced. And it is also seen by using any object oriented methodology, 3% of cost that we if you going through any traditional development approach, so whatever the cost that you will require to develop, so I mean 20 to 50% of amount of that cost will be able to develop the object, I mean using object oriented design approaches. Okay, so that is what the better, I mean it is one of the benefit you can see. That means we will be able to manage with 20 to 50% of cost what we actually invest if you going to develop any software using any traditional approach. So now there are there is a unified modeling language. Okay, so we'll talk about that, how we can going to model the objects that are part of our software, right? Because we're going through a software object oriented design. That means here we see, so very basic unit here is the object, right? Now then how you can model those different objects. Okay, so that is what exactly we'll talk about. So we'll try to use a modeling language. So it is actually not a system design or a methodology, right? So use it to document object oriented analysis and design. So here, so through this graphical representations, we will be able to document. I mean we try to specify we try to specify the requirements. Okay, so what I mean so this is what exactly we apply during object oriented analysis and design. So it is very much independent of any specific design methodology. So there are many design methodology, right? So when this particular language, modeling language, is completely independent of the specific design methodologies. So, so it was originated in late 1980s, and early 1990s. So we have seen there are many companies using various different notations. I mean notations to for this modeling, right? But after it is, so people have started to standardize these object-oriented modeling notations, because what was happening is, if there are 10 different companies, so 10 different companies were using 10 different notations. So as a result, it is quite difficult, uh, for the people who you see, you can think of like this. Okay, you are the developers, right? And you involved, maybe one is in Infosys, the other is in working in Wipro, right? Now, so they have used one object modeling language. I mean, notations were different in their modeling language, and now the person or the developer who is with Wipro, he might have learned the different notations. Now, after some days, maybe you can think of, they switched their organization, right? Maybe the person who was working in the Wipro, changed his job, from Wipro to Infosys. Now the person who was working with the Infosys now changed to Wipro. Now what happens? So because they have learned two different notations, again they have to learn their uh, the new technique notations, so as to uh, to keep himself continue the work in the particular current industry, right? So it's a difficulty, right? Now if you follow a single notation, what will happen? So now it will be very easier for different organization to integrate their work also, right? They can collaborate also. So that is what the idea, that is the reason why. So in 1990s, around 1990, so in between, so people were using different notations, but after that, so people started started to standardize. These are all different object-oriented modeling notations, right? Now, so basically, you can find many of these notations uh, in these books. Like maybe one is object modeling technique by Rambo, in the year 1991. Another is Booth's methodology, right? So Grady Booth. So in 1991, you can see there is another book, object oriented software engineering, Jacobson, right, in 1992. And Odell's methodology, in 1992. So Siller and Meller, so in 1992 also you can see. So they have different methodologies, right? You can see there are different methodologies, but now, so after taking all of these methodologies into account, and then so it is formed as a unified modeling language, right? So now we'll see that what is all, okay? So initially it was like this, okay? So there was something like this. There is a object modeling technique, there is a Booch methodology, there is a object oriented software methodology. Now you can see here, so now by taking all of these things, many of these advantages, I mean better notations from all of these things, now it become the UML, that is what unified modeling language. So we standardized, okay? That is what the idea. It's a standard, so adopted by Object Management Group. So in 1997, so they have adopted this UML as a standard, right? Uh, so the Object Management Group, so it's actually an association of different. They promote consensus maybe sometimes this UML also not only being used for the software development, it is also used in different other industries like car manufacturing industries. They also try to model their system using UML. So why UML is required? So model is required to capture only important aspects, right? So why do we try to model something? Because we wanted to understand certain important aspects of the system, right? So UML is a graphical modeling tool, as I told you, right? So easy to understand and construct also. You can easily specify your requirement, right? You can someone can easily understand, and also it is very much easy for us to construct also, right? So it helps in managing complexity. Okay, so it helps us in understanding a better complex problem, as well as a result you can better manage the complex problem also, right? Like the software, maybe managing of a large software. Okay, so there, if you have these UML diagrams, probably you will be able to manage the complexity of the software, right? So make it very simpler to understand. So there are 9 diagrams to capture different views of a system. So we'll see these all different 9 diagrams. Okay. So now if you see the recent versions of this UML, maybe you will be going to see there are around 14 diagrams. Okay. But we limit ourselves to 9 diagrams. Okay. Because of the time restrictions, right? So if possible, we can extend later on also, uh, you know, if we get time. So provide different perspectives of the software system. So by using these all different diagrams, UML diagrams, you will be going to give different perspectives of the software system, right? So always you try to capture different views of a system. Okay, so and these views can be captured through different diagrams. Hmm. Now, once you captured all of these different views of the system or the different perspectives of the software system, right? Now, thereafter, you can refine that particular diagram. Each and every diagram can be refined so as to, actually get the actual implementation of the system. So there are basically important 5 views of a system. What one view is user's view, the other one is structural, then behavioral, implementation, and environmental view, right? So we'll talk about each of the views. Okay, so now the same these are this diagram is also so you can at the actually the users there is a structural view. Okay, which can be represented which can be represented by a class diagram or a object diagram. We will talk about them. Okay, and your behavioral view will be captured through these are all 4 diagrams. So there is an interaction diagram. So as part of interaction diagram, we will be going through sequence diagram, collaboration diagram, and then you will have a state chart diagram, activity diagram. And then finally the implementation view. So there is a component diagram which will represent this particular view, right? And finally there is an environmental view. No, because we going to deploy the software no, so that is the reason why. So we'll capture this environmental view through a deployment diagram. So that means how you going to deploy that particular software and where you going to deploy that particular software, right? In what environment this software will be deployed. Okay, so these all things will be captured, right? So we'll talk about them. So your user's view. So the first view is it captures the view of the system in terms of functionalities offered by the system to its user. Okay, so when I say user's view, that means so what a particular user going to get different functionalities from a particular system. Okay, that is what exactly captured through user's view. That means what a user going to get from the system. I mean, how the user is going to interact with the system. Okay, so like you see, so when you're going through, when you if you talk about any ATM, bank ATM machine, okay, so in that case you see what a particular user expects. Okay, so there are two things, I mean few things, like maybe the user can go to go and use that particular ATM machine to withdraw money. Okay, or sometimes you can transfer money, or you sometimes deposit your money also. You can see the balance, how much amount balance that you have in your account. Mm. Or you can see the history of the different transactions, right? So these are the various important functionalities a user going to get from the system, right? So that view is actually captured through user's view. Okay, and it is a black box view of the system, right, where we do not know, I mean, how this will be implemented, what are the internal details of those things, not known. What we know is, so if I insert my card, if I give my PIN code or something like that, so I should be able to withdraw money from my account. But how these transactions are getting implemented, what's different logic, internal details, internal structure, everything is not known to us at this point of time, right? Now, so dynamic behavior of the components implementation etc are not captured. That is what we say. So right. So how those particular components of that particular software um, are going to behave dynamically when you give, so at this point of it black box view. That means these are the functionalities, high level functionalities a user going to get. So this is what exactly represented through a user's view. Okay, and there is a structural view. So this actually defines the structure of the problem. Okay, in terms of objects or classes. Okay, so I mean you can think of like, so you have a problem or a solution. Okay, that what are different classes of the objects, okay, you really need so as to implement that particular system. So this is very much, it's a structural view. Okay, because the number of objects whatever you are required for that particular system will never change. Okay, it is always constant, right? So you can easily understand, right? So if you talk about any ATM machine, okay, so bank ATM transactions, so what are the different objects that can be part of? Okay, so you can easily identify, and those things will not change. Okay, I mean once you identify that these many number of objects will be really there, so that will be there. Okay, so that is never going to change. So it captures the relationship among the classes or objects. So through this structural view, we will be able to see that how these objects are related to each other. That we will be going to see, but how they will be, how they going to show some sort of behavior by interacting with each other, those things will not be done here. Okay, that will be part of behavioral view. Okay, so now here is we will be going to see that what are the different classes, how these classes are related to each other, or what are the objects they are related to each other. Okay, so that will be only discussed, or that will be only represented, right? So it is that is the reason why it is called as the static model. So it is not a dynamic model. Okay, it is not going to change over time. Okay, so it will not change over time. The structure of the system will not change over time. Okay, now the behavioral view, so it actually captures how objects interact with each other in time to realize the system behavior, right? So let's say you wanted to see the behavior of a particular um, uh, you know maybe one particular behavior of that particular system you wanted to see. So now in order to accomplish that particular behavior, so certain number of objects they need to interact with each other. Okay, so with their interactions only you will be able to see the system behavior, right? we can talk about any objects, any real world system you can see, okay, where certain objects will be interacting to each other to accomplish a particular task. Okay, now this sort of, this behavior, if you wanted to capture, so that will be captured only through behavioral diagrams. Okay, so now the system behavior captures the time dependent behavior, right? So at different point of time, how that particular object is going to react to a particular activity, towards a particular activity. That is what we are going to capture. Okay, so it constitutes the dynamic model of the system. It is not a static model, it is a dynamic model, because at different point of time the objects will be behaving in a different way, so as to maybe to capture that particular uh, you know what you say, mm, to show that particular behavior, right? So there are, let's say you can think of like this. Okay, you have 10 different objects, and now these 10 different objects will be talking in different order, so as to accomplish a particular task. This is what, and if you wanted to capture that in which order, which order objects are talking to each other, are being exchanged, everything will be captured here. That is what we say behavioral view. And there is a implementation view. So it all captures important components of the system. That means what are the different software components that are really required, or that are part of a particular system. Okay, and their interdependencies and how they are dependent to each other. Okay, so that will be actually captured. For example, you can think of like, so you wanted to see the implementation view, uh, uh, maybe of a particular software, that is the GUI part, okay, or the middleware or the database part. And then so you wanted to see how they are dependent, how they are dependent to each other. Okay, how this GUI part is dependent on the database part, how this middleware is dependent on the database part, or how these sort of things will be captured through this implementation view, right? So when you going to finally implement, right? So you trying to see different parts that you have, right? And how you going to interface them, right? So what are the dependencies that they exist in between those parts, right? So those things will be captured through your implementation view. Okay, and finally, you have an environmental view, right? This view models how the different components are implemented on different pieces of hardware. Okay. Now, once those things, once you have implemented some of these components, right? Now then, um, now how you, I mean, what different components actually will be deployed on what part of that particular hardware, or maybe, so you have certain number of hardware pieces. Okay, so now you try to map the software components to different parts of the hardware. That means where you are going to deploy them, right? Let's say, for example, you can think of like this. Okay, so you have developed the software. Now that software may be going to interact with a particular piece of hardware, right? So, or you can think of if it is a embedded software, in that case what will happen? So whatever the software that you have developed, maybe you will have to deploy, and you have to implement that particular piece of code on a embedded hardware, right? So this is the way that you need to think, right? So you are trying to port them, right? To now, so the very first question it can comes to everyone is that are all these views really required, or only few certain number of views are really required? So that is a question, right? So actually, so the answer here is no. You do not require all of these views at all the time. Okay. So it all depends upon the kind of project we are developing, right? Let's say so as let's say you are going to develop a very simple system, right? In very simple system. In that case, maybe you need only one use case model, class diagram, and one interaction diagram may be enough. Okay, but if it is let's say for example so as part of that particular system, if you have lot many number of objects, and these objects they keep on changing the state, and these objects they keep on changing their state. Okay, so in that case you need to capture using a state chart diagram, right? And deployment diagram in case of, so you have a very large number of hardware components, as I told you, right? You have a very large number of hardware components, and these no, once the software components that are implemented, now you need to put them into all of these hardware components, right? So then only you really require this deployment diagram, right? But if you have a very few number of hardware components onto which you need to port the software pieces, right? So probably you do not require a deployment diagram, right? So something which can be very difficult for us to visualize, okay, or to understand something very, if it is something of very large, or it's a very it is of very complex in nature, then only we use all of these models, right? When you use these things, so it will be easier for us to understand, right? So developer and the customer, whoever may be going through, designer, whoever going through this, so will be easily, he can easily understand. That is what. Now, so as I told you, so use case is the one which is going to represent the user's view, right? So as part of a use case model, what you see, it consists of set of use cases, okay? And so usually, so you will be going to see different use cases. That means how a particular, in what way that particular user is going to use the system. Okay, what are the different ways through which the user is going to use the system. That is what exactly captured through a use case. Okay, so now as I told you, right? So if we take bank ATM, okay, machine, so in that case, so whenever user is going to a ATM machine, so what are the different ways he can use? So one way may be like this, so he can withdraw money from his account. The other way he can use that particular system is he can transfer money from his account to somebody's other's account, right? Or the third one is he can deposit money into his account. So these are the different ways the user is going to use the system, right? So that is what exactly we capture through a use case model, right? So now it is also very much important for analysis and design, right? So other models must conform to this model, right? So that means it is the first model, after which, different other models we will see, so they will also going to conform with this particular model. Okay, so they comply with this model, right? So not really an object oriented model. So it is not actually an object oriented model. So because here only we try to see what are the different high level functionalities of a system, right? Or how a user is going to interact, in what way the user is going to, in what are different ways the user is going to interact with the system. That is what captured. So here we are not talking about any object oriented things, right? So that is the reason why. So it is actually not an object oriented model, right? So it represents a functional process model. So almost it is a functional or a process model, right? Because you can see here the different number of functions, high level functions, right? So that is why. So that is the reason why, if you talk about any object oriented UML diagram, so it not only takes into the object aspects, but also it is taking the procedural aspects also. That is what. Different ways in which system can all high level requirements, right? So it all represents the transaction between the user and the system. That means how a user and system is, interacting, right? So you carry out one transaction. That transaction maybe you can think of like this. Okay, so withdrawing money. Okay, so that means one interaction, right? So a user is interacting with the system, right? Define behavior without revealing internal structure of the system. That means here we do not care about here at this point of time. We are not talking about the internal structure of that particular system, right? How the withdrawal will be done, how this cash transfer will be done, so those things are not talked about. Okay, what we we define only the behavior. What is the behavior, right? That means, but we are not giving any internal details, or we are not talking about the internal details of that particular behavior, right? Set of related scenarios tied together by a common goal, right? So always whenever you talk about any behavior, so that particular behavior together, maybe you a main activity. Okay, from that particular main activity, so maybe you have certain number of alternative paths. Okay, you have certain number of alternative paths. So then in that case we can say there are scenarios tied together. Okay, that means you can think of like this. Okay, let's say you wanted to withdraw money. Okay, so you wanted to withdraw money, right? So your main objective here is what? Withdrawing money from your account, right? So that means, so in order to withdraw money, what are the steps that you need to follow? First, you need to insert your debit card into the machine. Okay. Once after inserting that particular debit card, right, and then you need to give your pin code, right? Once you have given your pin code, and after that you will be taken into the main functionality, whatever you wanted to do. Let's say you wanted to withdraw money, so it will be taking you to the withdraw money option, and from there, when you click on that particular withdraw money, so maybe it will take you through different other steps, like how much money you wanted to withdraw, right? You will be entering that amount, right? Now you have entered that amount, and thereafter what will happen? The machine is going to give you money. So now this is the way various important steps as part of cash withdrawal. Okay, so you have this main behavior. That is what you want here the main behavior is that cash withdrawal. Okay, now with this cash withdrawal we have certain other scenarios tied. Okay, now one scenario can be tied with this is like this. Okay, let's say you have entered the pin. Okay, you have entered a pin, but if that pin is not a valid one, what will happen? Will you be able to withdraw money? No, you will not be able to withdraw money. That means maybe the system is going to ask you that you need to enter another correct pin. Maybe you forgot the pin. Okay, something. That means while you carrying out a main of when you are going through a particular steps for a particular main behavior, right? So there are certain other scenarios also tied together. The other scenario can be like this. Okay, so you have entered the amount to withdraw, but maybe at that point of time the amount that you entered is not available. That much amount of money is not available in your account. What will happen? So maybe some insufficient you know maybe the scenario is like this, insufficient money, right? So this is another scenario tied. Okay, so now you can see, so as part of a single important steps, okay, through which you can reach your goal, right? But with that particular goal you have certain other scenarios also tied together. Now that is what we say. Okay, so a set of related scenarios tied together by a common goal. Okay, that is what one use case. Okay, Is it clear so far, students?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So normally use cases are independent of each other, right? So now you see cash withdrawal is completely independent of money transfer, okay? Or maybe balance inquiry. So they are completely independent. They will be completely independent from each other, okay? So implicit dependencies may exist. So sometimes you may have some implicit dependencies, okay? Sometimes exist, okay, like in this case you can see in your as part of your library automation system, let's say there are two, one is a renew book and there is a reserve book. They are independent, okay, renewing a book and reserving a book, they are independent use cases, right? But in actual implementation, when you are going to implement these things, right, so now what is that, before you going to renew a book, before you going to renew a book, you need to make a, there should a check is made to see if any book has been reserved using reserve book or not, okay? So now you see renew book use case is completely independent and you are reserving a book is also independent, right? Their implementations, I mean their internal implementation will be very much different, but what, how they are dependent to each other, only like this, whenever you going to renew your book, first you need to check whether that book is already reserved or not. If it is reserved, then in that case what will happen, so it cannot be, it can't be renewed, okay? So that is what, so that means a use case can can dependent on, it can dependent on other use case also, right? But it is a very much implicit dependencies, okay? So that means you understand now. So sometimes you will have implicit dependencies also, right? So before you renew a book, so you will be going to see whether a book is reserved or not. So that will, that means this book will be, this use case will be actually dependent on the reserve book use case, okay? Now, so for any library automation system or information system, now you can understand these are the various use cases. Okay, one use case will be issuing a book. The other use case will be search a book or query a book, right? And the other use case can be return a book. Okay, return a book to the library, right? Or create membership, okay? Or you add a book into the library information system, right? That means you wanted to add a book into the library, new book, okay? So these may be these are the examples of use cases for a particular library information system. Is it clear?
Yes, sir.
Right. So now, so these different use cases, they can be represented by a use case diagram. Let's say for a particular project or a software system that you are going to develop, right? For which if you have identified certain number of use cases, now those use cases can be represented by using a use case diagram. Okay, so use case is represented by a ellipse. Okay, so this use case will be represented by a ellipse diagram, right? System boundary is represented by a rectangle. Okay, so that means the whole system, the boundary of that particular system, that means what is the scope of that particular system, okay, will be represented by a rectangle. Okay, so whatever the use cases that you will have, so identified those use cases will be part of that particular system. Okay, right? So that will be, so that means these are the boundary, you can give a boundary, so that boundary is represented by a rectangle. Okay, users are represented by a stick person icon. Okay, so we will see that an example where you can see there is a stick person. Okay, so a person is created, that's an icon actually created for each and every actor, okay, or the user. Okay, so user is actually going to interact with the use cases, right? So communication relationship between actor and use case by line. So the communication between the user and the use case will be represented by a line. Okay, so now you can see external system by stereotype. Okay, so we'll going through an example, then you can understand. Right now you can see here. Okay, so now the system boundary is represented through a rectangle. Okay, and with this particular system, within the system only you have only one use case, that is a play move. Maybe it is an example of a tic tac toe game. Okay, for which only you have only one use case, that is you going to give the move. So here is who is the user? So user is the player. Okay, so the player is actually going to play this game, right? So that means this particular player is going to interact. So user is communicating with this particular use case, so through a line. Okay, that means that line represents the communication, ellipse represents the use case, and your the boundary that you can see, so it is actually the boundary. The rectangle it shows here is the boundary. Okay, so that means within that boundary, so what are the different use cases that you have, okay, will be represented. Is it clear so far?
Yes, sir.
So why develop use case diagram? So it actually serves as a requirement specification also. That's a graphical way. It also actually helping us in specifying our requirements, right? So users identification helps in implementing security mechanism through login system. Okay, so you can think of, right? So as I told you, who are the different users going to interact with that particular system, right? Are going to interact with the use case, right? So you can always um, with some sort of, so you can identify different, let's say you can think of, right? So now so we have the Nitris software here, right? So now for this Nitris software, our institute Nitris software, right? So who are the different users? Who are the different users? Can anyone tell me?
So staff members, teaching or non-teaching.
Yeah, teaching, non-teaching. Other than that,
So students,
students. Other than
Students
that,
maybe.
other than that,
Sir,
network
any
developer.
organization who is having any project undergoing under NITR?
yeah. So usually, so whatever the projects that we have, right? I mean, for this particular system, so there are different types of users. Okay, one is a teacher. Okay, like the faculty members, right? The professors. Okay, they are also going to use this system, right? Students, they are also going to use this system, right? And you have the teaching staff. Okay, so you have the non-teaching staff, right? So they are also going to use, right? So like this, and also deans, directors, registrars, so various people, they're going to use it, right? Now if we classified, if we identified that these are the users going to use, these are the different use cases, right? Then what can happen? So you can provide accordingly different access to the use cases, right? That means now academic related things, um, so academic related things, you know, let's say for example, there is a user who needs to interact with the accounting package. Okay, that means the accountant is there in our institute. Okay, who needs to interact with the accounting package related use cases, right? But he has no role in having interactions with the academics related activities, right? So then we should not allow that particular accountant to communicate with the use cases that are part of academic activities, right? So now you can understand this way, right? So that means we can provide different access to different users, right? And also you can give a login, a login, login system also. You can also associate a login system for them. So is that only the people who comes with a kind of username password will be allowed to access the system. Another use in preparing the documents, right? So once if you have created these use case diagrams, it will help us in uh, preparing the user manual also at the end. So that way also it is going to help us. Now, so there is something called factoring of use cases, right? Sometimes if you have a very complex use case, so that need to be factored into simpler use cases, like in case of modular architecture, right? In as part of architecture we have seen, right? So whenever you have a very complex problem, so that can be divided into different layers of abstraction, right? So similarly here is also like this. Okay, if you have a very complex use case, now that can be factored into simpler use cases, right? Represent common behavior across different use cases. Okay, so there may be something like this, there is a use case which is going to show some common behavior across different use cases. Then you can factor out that particular use case, because that is the use case actually implicitly dependent on the various other use cases implicitly dependent on that particular use case. So in that case, you make that behavior as a common behavior, right? And you separate out that. So that shouldn't be part of all of these use cases. That is what we are trying to do. So here also we will see three different ways of factoring. One is generalization, include, and extend. Okay. So these are the three different ways we try to factor out or factoring the use cases. The first one here you can see is something like this. Okay, so this is what we call as generalization. We call it generalization. Now you can think of this example here, how you are trying to do. Now you have a pay membership fee. Okay, this is one use case. Okay, pay membership fee. Okay, now this payment can be, I mean, whatever the you are going to pay the membership fee, so that can be paid through credit card or it can be paid through library pay card. Let's say you wanted to, pay your membership fee. So maybe you have created a library card, then in that case you can pay that money through your library pay card or you can pay through your credit card. These are the two ways. Now what is happening here? So now you have there is little, you have a generalization, right? So that means you have a something, you generate. It is very much like you can think of you have a base class and you have a derived classes. Okay, so the derived classes are the ones, they are little different from the base class. Okay, they may have different other characteristics, right? So that is the same thing. So that is here is also we call as yeah, so as part of your use cases also we see the same inheritance concept, right? That is the generalization here. Okay, so that means you have a pay membership fee function or a use case, and now so this the smaller, pay through credit card is one of the use cases, which is actually a, you can think of it is a kind of derived use cases for this particular use case. Okay, so now this is what we call as generalization. Okay, is it clear so far? Generalization.
Yes, sir.
Yes, sir.
Okay, so now there is other one is a include. Okay, as I told you, so there is a use case you can you can. So as I told you, so if there is a very common use case, okay, that means that particular use case will be common for many other use cases. That means there is a implicit dependency. Okay, So in that case, you can use include. Like it is very much like you can see in your C programming language, why you try to include stdio.h, because that stdio.h library will is the one which which is common for all C programs, because most of the C programs will want to have certain input output operations, like maybe scanning data from the input devices, as well as giving some data to the display devices, right? So now you require always scanf printf kind of things. Because of this, so you always try to include that header file stdio.h. Similarly, you here also you can think of, there is a use case, so every other use case is going to use that particular use case, though in that case you can have include. Okay, so now you can think of this, okay, how we going to implement this use case, right? So now there is a issue book use case, and there is a renew book use case. Now, so before you issue a book, okay, or before you renew a book, you always go for this check for reservation use case. Okay, that means before you issuing a book, so you will check that whether that book is reserved or not. If it is reserved, then you cannot issue this. Okay, that means you have a dependency here, right? So understand. So now similarly, here is a renew book. Whenever you wanted to renew a book, so first you need to check that whether that book is reserved or not. If it is reserved, then it cannot be renewed again. Okay. Now this is the way that you can think of. Now this renew book is also you can think of, right? Any of this renew book you have, right? So it uses this check for reservation. Similarly, it also uses get user selection. Okay. So or update selected books. Okay, whenever so whenever you wanted to, once if you want to if you have removed this book, certainly you need to update that particular book. Okay, whether that book has been renewed or not, whether if it is renewed, then it should be updated in the library, right? So set of books. Okay, so this is the way that you can think of. You can include always certain number of use cases. The other one here is a extend. Okay, so extend use case, extends are the ones which will help you to add certain behavior or the certain use cases when certain conditions are met. Okay, that means you can think of like this. So for this base use case, if certain number of conditions are met, then only you will be going to use this common use case. Otherwise you will not be going to use. That means it is going to represent you the optional things. Okay, so sometimes it will appear, sometimes it will not appear. Okay, so these sort of things, if it is there required, so then you can represent through extends. Okay, so it is also similar to include, but it is optional. So it is going to represent the optional thing, right? So that means some conditions are met, only you are going to. Any doubt? Right. So now the other way, is part of use cases also. You can you can follow some sort of hierarchical organization also, right? Let's say you can think of like this. So you have at the higher level, so you have three different use cases, and then this use case 3 is further divided into three different use cases, right? So then it is a 3.1, 3.3. That means that is part of a particular subsystem, right? And then use case 3.3 can also be further divided into the different three use cases, right? So now you can again represent like this: 3.2.1, 3.2.2, 3.2.3. So this way you can further represent. Okay, so this is the way that you can create a hierarchical, you can create a hierarchical organization of different use cases. Okay, that can be represented. And also you can have a use case packaging also, right? So let's say for particular, these are the very much related use cases. Then you can package them all into one package. Okay, so now you can see, so the query balance, print balance sheet, okay, make payment, receive grant, these are all related to payment. Okay, so now they can be part of a account package. Okay, so these are that, so this is the way that you can create a packages of you can create use case packages also, right? So this is all about the use cases. So maybe in the next lecture we'll talk about the class diagram and all, right? So I stop. Any doubts so far, students?
No, sir.
Okay,
No,
can I stop
sir.
the lecture? Yes.